Hello, Algebra 2 Part 2. This is our third day working in parabolas, and so today we're going to be talking about how to figure out if they are wider or narrower than y equals x squared, finding the x-intercepts, and finding the y-intercepts. So these are some properties of parabolas that we can identify from their algebraic functions that can help us to identify what their graph will look like. So first off, how do you know if a parabola is wider or narrower than y equals x squared? Well, you can look at the coefficient on your a term, which is that first x squared term. And so if the coefficient, the number in front of x squared, is greater than 1, then the parabola will be narrower than y equals x squared. So to kind of give you an example of what this will look like, okay, if we have our, let's do a little bit smaller than that. So let's say we have just a pretty basic graph. Here's my x-axis, here's my y-axis, and then let's say we plot the parabola y equals x squared. Okay, and so if I have my a term is greater than 1, so let's say maybe I want to plot the parabola y equals 2x squared. So here, my a term is 2, okay? So that will be narrower than y equals x squared. And so what that would look like if I graph it is it would just sit right inside of the original parabola y equals x squared. And that's also true if it was negative. So for example, we would say we could have y equals negative 2x squared. So in that case, a is negative 2. So what that means is it's going to open down, but it'll still be narrower than y equals x squared, okay? So what you're looking at is the absolute value of a, okay? So if the absolute value of a is less than 1, then your parabola will be wider than y equals x squared. So an example of that, we'll go ahead and try to do that in yellow. So let's say I have y equals 1/2 x squared. Okay, so that's going to be wider, so that'll be a bit fatter, and so that'll hang out outside y equals x squared. And then we can do the same thing if it's the negative version, y equals negative 1/2 x squared, right? And so that's the same shape, except it's just going to open down. Okay, so you have a lot of different examples of different parabolas with different a terms. So the short story is, if the absolute value of a is greater than 1, it's narrower, and if it's less than 1, it's wider. And then, of course, if a equals 1, then the parabola has the same width as y equals x squared, and that doesn't really change its shape in that way. So the next thing we want to talk about is, how do you find the x-intercepts of a parabola? And so this is probably the most challenging part of dealing with parabolas, and maybe involves the most algebra in some cases, not all cases. In some cases, they're really easy to figure out, and then in some cases, you have to do a little more work. So when we're finding the x-intercepts of a parabola, the x-intercepts are the same thing as the zero of a function, and they're also the same thing as setting y equal to 0 and solving for x. Okay, so everything that you did at the end of chapter 5, when you had those equations that you factored and then you would set equal to 0 and solve, that's the same thing as finding the x-intercepts of the parabola. You can use that algebra. And then everything that you did at the beginning of chapter 8, by solving quadratic equations, by factoring, by taking square roots, by using the quadratic formula, by completing the square, those are all steps that we would take to find the x-intercepts of a parabola. So when you're finding the x-intercepts, essentially what you're doing is you're setting the quadratic equation equal to 0, and you're solving. Okay, now how you solve it depends on what the quadratic equation looks like. Your quadratic formula will work all the time, okay? That'll work all the time. Sometimes it's tough because not all square roots are perfect, but it's one method that works all the time. Factoring works some of the time if it's easy to factor, and completing the square, you can do completing the square, but I don't think that's a favorite method just because the algebra is kind of tricky on that. So my recommendation if you see the factors right away, go ahead and factor it, and you'll get your answers quickly. Otherwise, just go ahead and run through the quadratic formula. Okay, so negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, when we first started everything with parabolas, we said that it's possible to have 2 x-intercepts, no x-intercept, and 1 x-intercept, okay? And whether you have 2, 0, or 1 x-intercepts all depends on your discriminant. And a quick reminder that the discriminant is part of the quadratic formula. That's the part that's underneath the square root. It's just b squared minus 4ac. So, if b squared minus 4ac is positive, then you have 2 x-intercepts. If it's negative, then you have no x-intercepts. And if it's 0, then you have just 1 x-intercept. Okay, so that's a good way to kind of help you figure out what kind of parabola you're looking at. So if it's 2, 0, or 1. You don't necessarily have to do it. It's a good check, but that's the information there if it does come up, okay? And then the last thing that I want to go over is how you find the y-intercepts of the parabola. And this is really easy. All you do, well, it's really easy if your quadratic equation is in standard form. If it's in standard form, your y-intercept is just your c term. If it's not in standard form, plug 0 in for x and simplify. Okay, so that's probably one of the easiest things to do. So now we're going to go ahead and run through this classwork. And so with all of these, we'll start off by finding the x-intercepts, and then we can go ahead and answer these questions. And I think, well, let's see, y equals x squared plus 10x plus 25. I recognize that factors really quickly, so I'm going to go ahead and factor that. Let's see. So I'll kick it down here. So y equals x squared plus 10x plus 25, I recognize that factors into y equals x plus 5 times x plus 5. And so remember, when you're finding your x-intercepts, you're just setting it equal to 0 and solving. So then, well, I have 2 of the same factors, so I really only have to solve 1. So I'll just take 1x plus 5, set it equal to 0, and I solve for x, and x is negative 5. Okay, so that is my x-intercept. So then I can go up here and say my x-intercept is negative 5. Okay, now my y-intercept, well, that's just my c term, which is going to be 25. So I say my y-intercept is 25. Okay, I just pulled that just from the original function just by looking at it. Okay, and then wider or narrower than y equals x squared. So for that, we're just going to look at our a term, right? And then I can see my a term, well, it's just 1. It's the same thing as x squared. So we will say the same as y equals x squared. Okay, so let's go on to the second problem. So this one is in factored form for us, which is really nice. So that'll make it easy to find our x-intercepts. Okay, so we can take this down here. We have y equals x plus 4 times 2x minus 3, and I'm going to set the whole thing equal to 0 to find my x-intercepts. So then I'll separate these. So I'll have x plus 4 is 0, 2x minus 3 is 0. Solve each of those. So 1 x-intercept is negative 4, and then, let's see, I'll get 2x is 3, divide by 2, and then I get another x-intercept is 3/2. So I can go ahead and fill those in. So my x-intercepts are going to be negative 4 and 3/2, and then my y-intercept, well, the function that they gave me is not in standard form. I can still work with this to find my y-intercept. To do that, you're just going to plug 0 in for x. Okay, so that's, so let's see, we can plug 0 in for x to find the y-intercept. So I would get 0 plus 4 times 2 times 0 minus 3. So then I have 4. 2 times 0 is 0 minus 3. So 4 times negative 3 is negative 12. So that's my y-intercept. So y is negative 12. And then is it wider or narrower than y equals x squared? Well, to figure that out, I would have to do a little bit of foiling. You don't have to foil the whole way. You at least have to foil your first terms. So foil first terms to find the width. Now, if we look at what they gave us in the beginning, we had x plus 4 times 2x minus 3, okay? And if I multiply my first, x times 2x, I get a 2x squared. So then I can see that my a term is 2, which is greater than 1, so that means it's narrower. Okay? So it's narrower than y equals x squared. And those are our answers to number 2. So let's go ahead and take a look at number 3. So for number 3, let's see. Now, we want to find these x-intercepts, and if we look at this, it's not in standard form and it's not factored, but it is in a form that we could work with. So let's go ahead and set it equal to 0 and try to start solving it. Now we have something that's squared. It would be really easy to solve this if we could get this thing that's squared by itself. So I'm going to start off by adding 3 to both sides. And then I'll get 3 times x plus 1, the whole thing squared is 3. Okay, and remember, I want to get these parentheses that are squared by themselves. So then I'm going to go ahead and divide by 3, right? And that'll cancel out those 3's. So then I'll have So then I'll have x plus 1, the whole thing squared, equals 1. Okay, so now I have my parentheses squared all by themselves. That's a good thing. So now I'll go ahead and take the square root of those. And if you take the square root of anything squared, well, that's just going to give you what you started with. So that'll be x plus 1 all by itself. And then the square root of 1 is positive or negative 1. So now with this, we have to turn this into 2 equations to solve. So we have x plus 1 is positive 1, and x plus 1 is negative 1. So now we can solve each of these. So I'll minus 1, x is 0, minus 1, x is negative 2. So my two x-intercepts are 0 and negative 2. So then I can go up here, and I have two x-intercepts, x is 0, x is negative 2. All right, so then we have to find our y-intercept. So we can run through a similar type of process. Right, we can leave it in the form that it's in, okay? And then, again, we can just plug in 0 for x. So I'm going to have 3 times 0 plus 1, the whole thing squared, minus 3. And this will give me my y-intercept, right? So 0 plus 1 is 1. 1 squared is just 1. Simplifying that, I have 3 minus 3, which is 0. So your y-intercept is 0. So we can go ahead and fill that in over here. And then is this wider or narrower than y equals x squared? Well, to do that, we have to find our a term. And so this is in vertex form, right? And when you're in vertex form, you're actually given your a term. Your a term is what is in front of your parentheses. So for us, it's 3. And we can see that 3 is greater than 1, so that means it's going to be narrower than y equals x squared. And so we can answer that, okay? So the nice thing about vertex form is it does give you your a term. It's just whatever is in front of those parentheses. And if we couldn't see anything in front of the parentheses, then our a term would just be a 1. All right, so let's go on to number 4. So finding these x-intercepts, if we have any. So remember, to find your x-intercepts, you take your quadratic and you set it equal to 0. So let's see. I'll have y is negative 1/4 x squared, and I'll set it equal to 0, and I'll solve that, okay? So I'll get rid of my negative 1/4, divide both sides by negative 1/4, so I'm going to have x squared is 0, right? 0 divided by anything is just 0. So then it's looking like x equals 0, and that's my only x-intercept. And that's possible to have, Okay, now to find your y-intercept, well, remember your y-intercept is your c term. And so what we have here, this is in standard form, except it doesn't have a b term and it doesn't have a c term. So you can kind of picture it looking like plus bx plus c, but it's missing that, right? So then in this case, if it's missing those terms, you would say b is 0 and c is 0. So then our c term is 0, so then that means our y-intercept is 0. So then we can go down here, and our y-intercept is 0. And is this wider or narrower than y equals x squared? Well, our a term is negative 1/4. Your a term is negative 1/4, which is less than 1, so that means this is going to be wider than y equals x squared, and it would actually be fatter than that parabola. All right, so let's go down. Let's do number 5. So for number 5, we want to find our x-intercepts first. So we'll go ahead and take that equation and set it equal to 0. So I have y equals x minus 2, the whole thing squared is 0. Well, this is something, if we expand that, what that looks like is x minus 2 times x minus 2 is 0. So if you look at that, that's factored form. And so when we're solving factored form, we just take each factor, separate them, set them equal to 0, and solve. Well, in this case, both of them are the same, so we only have to do one of them. So I'm just going to say x minus 2 is 0, and then I can go ahead and solve that. And I get my x-intercept is 2. Okay, now to find my y-intercept, remember I plug in 0 for x, okay, because it's not in standard form, so I'm going to have to do that work. So let's see. So remember we say plug in 0 for x to find the y-intercept. So I'll have 0 minus 2, the whole thing squared, which is going to turn into negative 2, the whole thing squared, which is 4. So then our y-intercept is a positive 4. Okay, and then the last thing, is this wider or narrower than y equals x squared? So we'll have to do a little foiling. So remember, we said that this is the same thing as x minus 2 times x minus 2. And so we'll have to FOIL our first terms, okay, to get our a term. So if we do x times x, that gives us x squared. And so with that, we can see our a term is hiding, but it's 1. So then it's going to be the same as y equals x squared. Okay, so I think those are all of the classwork examples that we have. And so hopefully that gives you a good summary of how to find the x-intercepts, the y-intercepts, and whether or not your parabola is wider or narrower than y equals x squared. And you can go ahead and try the homework.